NASA X-59, History, Present and Future. Introduction. NASA's X-59 quiet supersonic technology aircraft is a groundbreaking project at the forefront of aeronautics research aimed at revolutionizing commercial supersonic air travel over land. As the centerpiece of NASA's Quest quiet supersonic technology mission, the X-59 is designed to overcome the challenges posed by sonic booms which have historically prohibited supersonic flight over populated areas. This report outlines the history, current status, and future prospects of the X-59 aircraft, highlighting its significance for aviation and global travel. History of the X-59. Early research and development. The journey toward the development of the X-59 began in 2003 when NASA initiated the Shaped Sonic Boom Demonstration Program. This program focused on exploring how the shape of an aircraft could mitigate the intensity of sonic booms. Through innovative design and engineering, researchers aimed to create an aircraft that could fly faster than the speed of sound while generating minimal noise on the ground. Assembly and testing milestones. In 2020, assembly of the X-59 commenced at Lockheed Martin's Skunk Works facility in Palmdale, California. Despite the challenges posed by the COVID-19 pandemic, progress continued with the aircraft's unique design taking shape. By 2022, NASA anticipated the completion of the X-59's assembly and the initiation of ground tests. Engineers implemented advanced technologies such as the External Vision System (XVS), which utilizes high-resolution cameras to provide pilots with visual information, compensating for the aircraft's lack of a traditional forward-facing cockpit window. Key developments. In 2023, NASA planned acoustic validation flights to confirm that the X-59 could produce a quiet thump instead of a disruptive sonic boom. These tests were crucial for demonstrating the aircraft's capabilities and gathering data necessary for regulatory considerations. Present status of the X-59. Unveiling and public engagement. On January 12, 2024, NASA and Lockheed Martin unveiled the X-59 to the public at a ceremony at the Skunk Works facility. This event marked a significant milestone in the project, with officials expressing optimism about the aircraft's potential to transform air travel. The unveiling attracted global attention, with thousands of viewers participating in watch parties across multiple countries. Technical specifications. The X-59 is designed to fly at speeds of 1.4 times the speed of sound, equivalent to approximately 925 miles per hour. Its elongated nose, measuring over 30 feet, plays a critical role in reducing shockwaves and minimizing sonic boom noise. The aircraft's innovative design features include thin tapered nose. This design helps disperse shockwaves, thereby reducing noise on the ground. Engine placement. The engine is mounted above the fuselage to prevent shockwaves from merging and creating a boom. External Vision System (XVS). High-resolution cameras provide pilots with a clear view of their surroundings via a monitor in the cockpit. Flight testing plans. Following the rollout, the next significant steps for the X-59 include integrated systems testing, engine runs, and taxi tests. The first flight is targeted for later in 2024, after which the aircraft will conduct community overflights to gather public reactions to the sound it produces. Future prospects of the X-59. Regulatory impact and market potential. The primary goal of the X-59 is to collect data that will inform regulatory bodies, such as the Federal Aviation Administration (FAA) and the International Civil Aviation Organization (ICAO), regarding the feasibility of allowing commercial supersonic flight over land. By 2027, NASA plans to deliver flight data to these organizations, which could lead to a reassessment of existing regulations prohibiting supersonic travel. The successful demonstration of quiet supersonic flight could open new markets for commercial aviation, drastically reducing travel times. For instance, a flight from New York to Los Angeles, which typically takes about 6 hours, could be completed in under 3 hours with supersonic capabilities. This transformation would not only benefit passengers by saving time but also enhance global connectivity. Long-term vision. NASA's Quest mission embodies a long-term vision for the future of aviation, aiming to integrate advanced technologies that prioritize efficiency and sustainability. The X-59 represents a significant leap forward in aeronautical innovation, potentially paving the way for a new generation of commercial aircraft designed with similar low-boom technologies. Conclusion. The NASA X-59 quiet supersonic technology aircraft stands at the intersection of innovation, regulatory reform, and the future of air travel. As the project progresses through its flight testing phase, its success will be pivotal in determining the future landscape of commercial supersonic flight over land. By addressing the challenges of sonic booms, the X-59 not only symbolizes a significant achievement in aviation technology but also heralds a new era of faster, more efficient global travel. With continued support and successful data collection, the dream of quiet supersonic travel could soon become a reality, reshaping the aviation industry for generations to come. The NASA X-59 quiet supersonic technology aircraft represents a significant advancement in aeronautics, primarily focused on overcoming the challenges associated with supersonic flight over land. The project's core aim is to address the long-standing U.S. ban on such flights, which has been in place for over 50 years due to the disruptive nature of sonic booms. By utilizing innovative design and technology, the X-59 aims to produce only a soft thump noise instead of a loud sonic boom, thereby potentially paving the way for commercial supersonic travel. Historical context and development timeline. 1. 2003. The initiative began with the Shaped Sonic Boom demonstration program, where NASA explored how aircraft shape could mitigate sonic boom intensity. This early research laid the groundwork for the X-59's design. 2. 2020. The assembly of the X-59 progressed at Lockheed Martin's Skunk works in California, despite setbacks from the COVID-19 pandemic. This period marked a critical phase in bringing the conceptual aircraft into physical form. 3. 2022. NASA projected that the assembly would be completed by summer 2022, followed by ground testing. This timeline was ambitious, reflecting the project's urgency and importance. For 2023, the focus shifted towards acoustic validation flights, a crucial step to confirm the aircraft's ability to achieve its design goals of quiet supersonic flight. 5. 2024. The X-59 was officially unveiled on January 12, 2024, marking a milestone in its journey. Later in the year, NASA planned to commence flights over select communities to gather public feedback on the aircraft's noise levels. 6. 2027. Data collected during community flights will be shared with regulatory bodies like the FAA and the International Civil Aviation Organization, potentially influencing future regulations on supersonic travel. Technological innovations. The X-59 incorporates several groundbreaking technologies and design features aimed at minimizing sonic boom noise. Extended nose design. The aircraft's elongated nose plays a critical role in reshaping shock waves to reduce noise. This design modification is essential for achieving the soft thump instead of a loud boom. External Vision System XVS. Due to the aircraft's unique shape, the cockpit lacks a forward-facing window. Instead, it utilizes a sophisticated camera system that provides pilots with a real-time view of the outside environment displayed on high-resolution monitors. Engine placement. The engine is mounted on top of the aircraft, a strategic design choice that helps to control and dissipate shock waves, further reducing the noise generated during flight. Counterintuitive aspects. 1. Perception of noise. While the X-59 is designed to produce significantly quieter noise levels, the public's perception of noise is complex. The expectation that people will simply accept the new quiet thump is counterintuitive, as individual experiences and sensitivities to sound can vary widely. This means that while scientifically the noise may be quieter, public acceptance will depend on subjective experiences. 2. Regulatory challenges. Despite the technological advancements, there remains skepticism about whether data collected from the X-59 flights will lead to regulatory changes. Historical precedents show that changes in aviation rules can be slow and fraught with political hurdles even when presented with compelling data. 3. Public reaction to supersonic flight. The assumption that a quieter sonic boom will automatically lead to renewed public enthusiasm for supersonic travel could be misleading. Many consumers may still associate supersonic flight with high costs and environmental concerns, which could dampen the anticipated market resurgence. 4. Environmental considerations. The X-59's design aims to mitigate noise pollution. But there are broader environmental implications associated with supersonic travel that are often overlooked. Considerations like fuel efficiency and greenhouse gas emissions may temper the excitement around the X-59's potential commercial applications. Future implications. The successful deployment of the X-59 could herald a new era in aviation, enabling faster-than-sound travel for commercial flights over land. The data gathered from its operations will be crucial in shaping future regulatory frameworks, which could allow for a resurgence of supersonic travel, potentially transforming global travel dynamics. However, the project also serves as a reminder of the complexities involved in the intersection of technology, public perception, and regulatory environments. While the X-59 represents a leap forward in aeronautics, its ultimate impact will depend on a multifaceted understanding of these factors. In conclusion, NASA's X-59 is not merely an aircraft, it is a symbol of innovation, ambition, and the potential to reshape the future of air travel. Its development encapsulates both the challenges and opportunities of modern aeronautics, illustrating that overcoming deeply ingrained barriers requires more than just technological advancements. It necessitates a comprehensive approach that incorporates public perception, regulatory frameworks, and broader environmental considerations. The NASA X-59 quiet supersonic technology aircraft, part of the Quest mission, is a pivotal development in aerospace technology aimed at enabling commercial supersonic flight over land by mitigating the disruptive sonic boom associated with such speeds. While the general narrative surrounding the X-59 highlights its innovative design and technological advancements, several critical aspects of the project are often overlooked yet hold significant implications for both the aviation industry and environmental considerations. The significance of the X-59's design features. One of the most noteworthy features of the X-59 is its elongated nose, which is a critical design element intended to reduce the intensity of sonic booms. This design choice is not merely an aesthetic decision, it reflects decades of research into aerodynamics and sonic boom mitigation. The X-59's unique shape is engineered to break up shock waves that would otherwise coalesce into a loud sonic boom, transforming it into a quieter thump. This innovation is significant because it challenges the long-standing regulatory barriers against supersonic flight over land, which have been in place for over 50 years due to noise pollution concerns. The role of the External Vision System (XVS). Another feature that deserves attention is the X-59's External Vision System (XVS). The decision to forego a traditional forward-facing cockpit window in favor of a high-resolution camera system is indicative of the aircraft's advanced technological approach. This system not only enhances pilot visibility but also underscores a broader trend in aviation towards automation and reliance on advanced sensory technology. The use of augmented reality to assist pilots could revolutionize cockpit design and operational safety in future aircraft, a point frequently overshadowed by discussions of noise reduction and speed. Data collection and regulatory impact. The X-59 is not merely an experimental aircraft, it is a crucial data-gathering platform intended to influence regulatory frameworks governing supersonic flight. The planned community overflights to collect public perception data regarding the noise generated by the X-59 are particularly significant. This initiative represents a proactive approach to regulatory engagement, enabling the collection of scientifically valid data that could lead to substantial changes in aviation regulations. The data gathered will be submitted to the Federal Aviation Administration (FAA) and the International Civil Aviation Organization (ICAO), marking a significant step towards potentially lifting prohibitions on supersonic travel over land. This aspect of the project is critical as it bridges the gap between technological innovation and legislative change. A connection that is often overlooked in discussions of aerospace advancements. Environmental considerations. An important yet frequently neglected aspect of the X-59 project is its potential environmental impact. While supersonic flight is often criticized for its carbon footprint and noise pollution, the X-59 aims to address these issues head-on. By reducing the noise associated with sonic booms, the X-59 could pave the way for more environmentally sustainable air travel options. Moreover, if commercial supersonic flight becomes viable, it could lead to reduced travel times, potentially leading to fewer aircraft in the sky at any given time, which might mitigate overall emissions. This consideration aligns with global efforts to reduce aviation's environmental impact, a topic of growing importance among consumers and regulators alike. The broader implications for air travel. The successful implementation of the X-59 could have far-reaching implications for the future of air travel. It opens up the possibility of new commercial routes and faster travel options, fundamentally altering the landscape of air transportation. The prospect of flying from New York to London in under 3 hours rather than the typical 7 has profound implications for business and tourism. However, the discussions around the X-59 often focus solely on the technological achievements without fully considering how these advancements could reshape global travel dynamics and economic activity. The historical context. The historical significance of the X-59 project cannot be understated. It represents the culmination of decades of research into supersonic flight and noise mitigation. Past attempts at commercial supersonic travel, like the Concorde, faced significant obstacles primarily due to noise regulations. The X-59 therefore is not just a technological advancement, it is a historical pivot point that could determine the future viability of supersonic travel. This historical context is often overshadowed by the excitement surrounding its unveiling and technical specifications. Conclusion. In conclusion, while the NASA X-59 quiet supersonic technology aircraft is celebrated for its innovative design and the potential to revolutionize commercial aviation, several significant aspects of the project are often overlooked. The implications of its design features the role of advanced technology like the XVS, the proactive approach to regulatory change, environmental considerations, and the broader impacts on global air travel are all critical elements that underscore the importance of the X-59 project as it moves into the flight testing phase and beyond. The X-59 has the potential not only to redefine supersonic travel but also to set a precedent for how technological advancement can align with regulatory frameworks and environmental sustainability. 1. Historical context and development of supersonic flight. The X-59 represents a significant milestone in the evolution of supersonic flight technology, particularly over land. The historical context of sonic boom research dates back several decades, with NASA's early experiments in 2003 through the Shaped Sonic Boom Demonstration Program showcasing the potential to reduce sonic boom intensity through aerodynamic design. This foundational work paved the way for the X-59's development, emphasizing the need to overcome regulatory barriers imposed since the 1970s due to public disturbances caused by sonic booms. The X-59 aims to demonstrate a technological breakthrough that could allow commercial supersonic travel over land, thus significantly altering the landscape of air travel and potentially leading to a resurgence in supersonic commercial aviation. 2. Technological innovations. The X-59 incorporates groundbreaking technologies that distinguish it from earlier supersonic aircraft. Notably, its elongated nose design is critical in minimizing the sonic boom, transforming it into a quieter thump. The aircraft also utilizes an innovative external vision system (XVS), replacing the traditional cockpit window with high-resolution cameras and augmented reality displays. This adaptation is necessary due to the unique cockpit placement which enhances the aircraft's aerodynamic profile. Furthermore, the integration of advanced manufacturing techniques such as robotic drilling systems demonstrates NASA's commitment to modernizing aerospace production processes. These technological innovations are not just about performance, they are crucial for regulatory acceptance and market viability of future supersonic commercial flights. 3. Regulatory impact in future commercial markets. A central goal of the X-59 project is to collect data that will influence regulatory frameworks governing supersonic flight over land. By 2027, NASA plans to present findings to the International Civil Aviation Organization ICAO and the Federal Aviation Administration FAA, potentially leading to policy changes by 2028. This regulatory aspect is vital for opening new markets for commercial supersonic travel, which could drastically reduce flight times and reshape global travel dynamics. The success of the X-59 could catalyze the development of a new generation of supersonic airliners, fundamentally altering air travel experiences and offering significant economic benefits to the aviation industry. 4. Public engagement and perception. The approach NASA is taking with the X-59 emphasizes the importance of public perception in the acceptance of new aviation technologies. Scheduled community overflights are designed to gather feedback on the sound produced by the aircraft, directly addressing public concerns about noise pollution. This engagement is crucial for informing regulators and the industry about community reactions, which can influence the future of supersonic flight regulations. The proactive strategy of involving the public in the testing process not only aids in data collection but also fosters transparency and trust, which are essential for the successful integration of supersonic travel into existing air traffic systems. This focus on public sentiment underscores a broader trend in aerospace development, where stakeholder input is increasingly recognized as critical to project success. 1. Concorde 1969–2003. The Concorde was a turbojet-powered supersonic passenger airliner that operated from 1969 until 2003. It was known for its ability to cruise at over twice the speed of sound, Mach 2.04 or 1,354 miles per hour at cruise altitude. The Concorde was a product of a joint venture between British and French manufacturers and served transatlantic routes, cutting travel times significantly. However, it faced challenges such as high operational costs, limited seating capacity, and the sonic boom issue, which restricted its flights over land. The Concorde's retirement marked the end of an era for commercial supersonic travel. 2. Lockheed State Route 71 Blackbird 1966–1998. The State Route 71 was an advanced long-range Mach 3 plus strategic reconnaissance aircraft that served the United States Air Force. Its design was pioneering for its time, utilizing innovative materials and aerodynamics to achieve high speeds and altitudes. The State Route 71 could outpace surface-to-air missiles and interceptors, making it a key player in Cold War reconnaissance. While it wasn't a commercial aircraft, its technological advancements in supersonic flight and stealth have influenced future aviation designs. The aircraft's retirement was largely due to the rise of satellite reconnaissance and high operational costs. 3. Boeing 2707 1970s. The Boeing 2707 was a proposed supersonic transport SST aircraft that aimed to compete with the Concorde. The project was ambitious, featuring a variable sweep-wing design intended to improve performance and fuel efficiency. However, the development faced numerous challenges, including high costs, technical difficulties, and environmental concerns over noise pollution and emissions. The project was ultimately cancelled in 1971 due to these factors, marking a significant setback for the pursuit of supersonic commercial aviation in the United States. The cancellation of the 2707 reflects the complexities involved in developing supersonic aircraft that can meet regulatory and public acceptance standards. Future outlook: predictions for the NASA X-59 project. The NASA X-59 quiet supersonic technology aircraft represents a pivotal advancement in aviation technology, particularly in the realm of commercial supersonic travel. As the project progresses, several key predictions can be made about its future impact, regulatory changes, and technological advancements. 1. Regulatory changes by 2028. One of the primary goals of the X-59 project is to alter existing regulations that currently prohibit supersonic flight over land due to the disruptive nature of sonic booms. By conducting extensive flight tests and gathering data on the X-59's quieter sonic thump, NASA aims to provide compelling evidence to regulators. By 2028, it is anticipated that the International Civil Aviation Organization ICAO and the Federal Aviation Administration FAA might revise their policies based on the data collected, potentially leading to the approval of commercial supersonic flights over land. 2. Commercial supersonic flight resurgence by 2030. Assuming successful regulatory changes, commercial supersonic flight could see a resurgence by 2030. Airlines may begin to introduce new supersonic aircraft into their fleets, catering to high-demand routes and significantly reducing travel times. This could open new markets for aviation companies, allowing them to serve business travelers and long-distance commuters more effectively, with flight times cut by as much as 50%. 3. Technological innovations in future aircraft designs. The X-59 is not just a prototype. It is a testbed for advanced technologies that will likely influence the design of future aircraft. Innovations introduced through the X-59, such as the External Vision System (XVS), which compensates for the lack of a forward-facing window, could become standard in next-generation aircraft. Furthermore, technologies developed for noise reduction and aerodynamic efficiency could be integrated into future commercial and military aircraft designs, enhancing both performance and environmental sustainability. 4. Increased public acceptance of supersonic flight. Public perception of supersonic travel has been historically negative due to concerns over noise pollution. However, the data collected during community overflights of the X-59 is expected to demonstrate that the aircraft's noise is significantly less disruptive than traditional supersonic jets. This could lead to increased public acceptance of supersonic flights, particularly if the flights are marketed effectively, emphasizing the benefits of reduced travel times and minimal noise impact. 5. Environmental considerations and sustainable aviation fuels. As the aviation industry faces increasing pressure to reduce its carbon footprint, future supersonic aircraft informed by the X-59's development are likely to incorporate sustainable aviation fuels (SAFs) and advanced propulsion technologies. The integration of these eco-friendly technologies will not only comply with environmental regulations but could also enhance the public's perception of supersonic travel as a viable option for sustainable aviation. 6. Global market expansion by 2035. By 2035, as regulations evolve and public sentiment shifts, a global market for commercial supersonic travel could emerge. Regions like Asia, Europe, and North America may see the establishment of transcontinental supersonic routes catering to high-value passengers. This expansion will likely be facilitated by partnerships between governments and private companies, leading to a revitalization of the aviation sector post-pandemic. 7. Integration with urban air mobility solutions. In the longer term, advancements from the X-59 project may integrate with urban air mobility solutions, creating a seamless transportation network that includes supersonic travel. The ability to connect major urban centers with rapid transit options could revolutionize how people travel within and between cities, potentially leading to the development of supersonic air taxis or commuter vehicles. Conclusion. The NASA X-59 project holds transformative potential for the future of aviation. With successful flight tests and data collection, it could lead to significant regulatory changes by 2028, paving the way for a new era of commercial supersonic travel by 2030. As technological innovations emerge and public acceptance grows, the X-59 will not only influence future aircraft designs but may also play a critical role in shaping a more efficient, sustainable, and interconnected world of air travel.